I want to thank Jeff for responding and appreciate you being here today. So just a little bit about his background. So prior to co-founding Cloudera, and I'll let you, when we talk, I'll let you share a little bit about Cloudera and what you do there. But he conceived and built the data team at Facebook. So I think you were one of the first 50 or 100 employees thereabout at Facebook, so really early on, and built the infrastructure that became the back end for that system. And you know, of course, when you talk about data, you know, we don't have big data in this industry. That's an overused term, but you know, we have a lot to learn. In fact, many of the things we've done have been looking at what happens outside of healthcare, what ideas and innovations can we come and bring back to healthcare and behavioral healthcare. So really coming from a you know, large-scale data analysis, he's got a great perspective and can help us there. You know, currently, in addition to his work with Cloudera, he is very engaged with Mount Sinai in New York, working with them on you know, getting more out of their data. So he's very focused on healthcare and the opportunities that data presents, and how you also do science, and how science is transforming itself from just a hypothesis-driven research, you know, randomized controlled trial model to a more iterative model where you can gain knowledge from the data, do it in an appropriate and considerate way, and then feed that data into science so we can gain knowledge and improve practice. So with that, we're going to just have a conversation for a few minutes, and then we'll open it up to questions with the group and have a broader conversation. So I'm very excited, Jeff. If you'd like to come up, we can So thanks again for being here today.
You bet. Is this all working well? Okay.
Yeah, it's perfect. So I think it's probably helpful just to start at the beginning, and it'd be great to hear from you about you know, what led you to Cloudera and what has led you to your current work and with Mount Sinai and where that's leading.
Sure. I'll try and keep it slightly condensed. So I was at Facebook for about 2.5 years, and as you mentioned, sort of built from scratch the infrastructure for storing the data that was generated by the website for offline analysis. And so we grew that data store from 0 to well over a petabyte of data over the course of a few years, and did so primarily with open source software running on commodity hardware. So we did it at much lower cost than we would have been able to do it with commercial software. So through that process, I became quite familiar with the enterprise software vendors and the startup companies who were attempting to tackle the problem of scalable analytical data management infrastructure. And I really felt like we had built something at Facebook in conjunction with a few other organizations in this open source project called Apache Hadoop that would be broadly applicable. And so with Cloudera, the idea was to take the software that we were building inside of Facebook and commercialize it in the same way that Red Hat has done with Linux, to bring it to a much broader audience than just consumer web properties, who are the primary contributors to the open source project. That being said, my background, my undergraduate degree is in mathematics, and my background is really in doing data analysis, not building infrastructure software. So after about 4 years of building Cloudera, I became interested in becoming an end user of the software again. And through a fairly circuitous path, I serve on the board of directors of a nonprofit called Sage Bionetworks. Sage Bionetworks is attempting to build sort of a globally coherent data sets about disease for disease modeling and drug discovery, and make those open and available to everyone. And through that process, another member of the board of directors there is a guy named Eric Schott, and Eric was hired at Mount Sinai and given a fairly large budget to build an institute which was applying the tools of scalable analytical data management to the data being generated inside of the hospital. And so through the process of talking with him about what I was interested in doing next and what he was working on, we kind of carved out a way in which I could sort of have two employers. So I'm still employed by Cloudera as our chief scientist, but I also am employed at Mount Sinai as an assistant professor. So I kind of split my time between coasts, and at Cloudera I'm tool building, and at Mount Sinai I'm tool using, and each I find informs the other.
How do you, in the work at Mount Sinai, what are the kinds of questions that you're interested in? Where do you see that leading?
Yeah, so early on, there's just a tremendous amount of domain knowledge that I need to build. So I don't really plan on authoring my own scientific hypotheses in the first year or two. So the kinds of questions I'm addressing are the ones that seem most important to the people in the department within which I find myself, which is the Department of Genetics. So I've been just paying attention to which projects have a real head of steam and are kind of crossing the boundaries of multiple different labs. And then I try and participate in their meetings and understand what they're working on and see if there's a way that the software tools that I'm familiar with building could help, or if there's a new tool that I could help, that I could build for them that would help them do their research faster. So the first two areas that have really emerged as these kind of cross-lab collaborative problems to solve. The first is personalized cancer therapy, where we do molecular profiling of a patient and their tumor and kind of try and identify novel therapeutic regimens based on data analysis of the patient and their tumor. And then the second is hospital-acquired infections. So it's Mount Sinai just merged with Continuum to form the Mount Sinai Health Network, and we're now I believe I've heard quoted the third largest nonprofit medical center in the United States, or medical network in the United States. So we have a very, very large number of people coming through. We have 7 different campuses, and something like 1 in 20 people on average in the United States will acquire a hospital-acquired infection during a stay in the hospital. So it's a huge both health and financial burden on the hospital. So better quantifying and characterizing that. But as you know, my kind of long-term interest is diseases of the central nervous system and mental health in particular. So we do have some leading researchers in the institute at Sinai. Pamela Sklar in her lab, she works with some folks, a guy named Sean Purcell and Menachem Fromer are the two sort of data folks that I know from her lab. They've done some very interesting work that's fairly high profile with a large consortium on identifying sort of the genetics of mental disorders, and they've found some interesting things about similar copy number variations that are present. Copy number variation is one kind of mutation that could be present in your DNA, and they found that a similar set of copy number variations present in both schizophrenia and bipolar mood disorders. So there's some notion that there may be a genetic similarity between those that they're finding. So I pay attention to their work, but so far haven't been able to contribute.
So when you think about, given one of the things that's interesting about Cloudera is it actually takes this infrastructure, this data infrastructure, and makes it a cloud-based service. And how does that, when you think about smaller organizations, it's sort of easy to imagine for larger organizations and even for organizations like Mount Sinai how that is important. How does that matter for smaller organizations?
Mm-hmm.
And how do smaller organizations begin to leverage the kinds of findings that can occur at scale, at big scale?
That's a good question, and the reality is at Cloudera we initially built a cloud service in hopes that that was sort of the future and it would be our vector of disruption, but the reality is the vast majority of our customers end up running our software on servers that they themselves own. So the sort of great migration to the cloud has, in practice, I think, particularly for scalable data management and analysis, has been slower than the press would have you believe. That being said, the point is an entirely valid one, which is how are small or medium businesses able to take advantage of this trend. It's difficult to say. There's certainly an expertise gap. A small business doesn't necessarily want to hire world-class IT staff to build every aspect of their business. So cloud architectures can be ways in which they can avoid having to build expertise in an area that's non-differentiating. As Jeff Bezos says, the non-differentiable heavy lifting. There's no reason that every business should have to be doing that. But that being said, there were ways to do that prior to public cloud infrastructures, where you could just go to hosting providers, rent colo space, et cetera. So I think the more important trend is when does it make sense for a small business to try and analyze very large bodies of data? And with commodity hardware and open source software, whether that commodity hardware lives in a cloud data center or one that you yourself manage, you can manage very large amounts of data for very small amounts of money. So for the cluster that I'm building at Mount Sinai, all in software, hardware, shipping, installation, I'm paying under about $180 a terabyte, which means I can store a petabyte of data for less than $200,000, which is roughly the cost of one fully loaded employee. And that's a petabyte of data. So that's an incredibly large amount of data for not a significant cost. So all of a sudden, the kinds of problems that are addressable by small businesses, I think, expand. And you can see this with companies like Tumblr had less than 30 employees at the time of acquisition and serviced hundreds of millions of customers. Instagram was in a similar scenario. I believe they even had less than 20 employees. So I think that companies are now adjusting, and small businesses can now think about, well, what could I do if I had a petabyte of data? And it takes a while to change your thought processes. So the work that I'm doing with the infection control unit at Mount Sinai, it was interesting because we were having a conversation about tracking all the different patients in the hospital and wanting to see when they got infected. And near the end of the conversation, the woman who ran the department said, okay, good, so let's pick one of the bacteria that we can start with so that we don't overwhelm you with the amount of data. I just kind of laughed because we're talking like 1,000 patients. And I'm like, you realize that this software can handle a billion people banging on it every day. So I think like our 1,000 patients, we're going to be, so you really kind of, in the practitioners and the people with the domain expertise, they need to evolve their understanding of what is possible to the point where they start asking questions that can only be answered with a petabyte of data.
I think that's, it takes me to thinking about what does that mean for the generation of knowledge. So, I think healthcare in particular, but all of sort of our traditional notions of science have been very focused on, the randomized controlled trial, the gold standard of scientific research. And, there are new opportunities based on the data volume available to us now, but it's also very dangerous because you can't, there are more spurious findings than ever before. So how do you sort of balance the two, sort of the scientific method with discovery, and how do you see that model forming?
Yeah, it's evolving. There was a really interesting set of lectures given by that I believe we talked about on the phone, a guy named Sir Michael Rawlins, a few years ago, where he tries to really articulate the set of biases about evidence in the medical field. So we all have qualitative notions of how good different evidence is. So you read a study and you think, you have a certain qualitative understanding of how good the evidence in that study was, but he's talking about trying to actually force us to quantify that notion of how good is this evidence that we found here. And I think with randomized controlled trials, you start to hit issues around external validity, for example. So if you look at the people who are enrolled in randomized controlled trials and the people that exist outside of them, they often don't match very well. You start to hit issues around post-market surveillance. So you perform the randomized controlled trial and you kind of let your guard down because it's made it through this gauntlet, so you presume it works. And so then you rely on people like Kaiser Permanente doing population health studies and finding that like Vioxx is killing people. So we really need to rethink our notion of scientific evidence to be broader than just a randomized controlled trial. And in particular, you start to see, so randomized controlled trials can be powerful, and they're used in the consumer web in a very high throughput fashion. So we run very low cost, very high throughput controlled trials, like hundreds of thousands, if not millions a day on sites like Google and Amazon and Facebook. And so bringing this notion of much lighter weight, higher throughput, so like shortening the cycle time on hypothesis to conclusion, I think would be very valuable to the healthcare system, but also additional work on robust causal inference in observational studies. So you see methods emerging from labs like Gary King's lab at Harvard, in the Institute for Quantitative Social Sciences, and even Google has written some interesting papers on tools for doing robust causal inference in observational studies. And the reality is the vast majority of data that we have to analyze is observational in nature and not controlled. So let's build the, it's a challenge to the statistics community, and it's a challenge to the provider community to then know how to work with the results provided to us by the statistics community. So I think there's no silver bullet. It's not like there's something just over the horizon that once we figure it out, all of a sudden we're just going to unleash. I just think that we need to be open to evolving what is really just sort of a historical artifact. It's not like the randomized controlled trial is this thing that was like written in stone and handed to us. It's like over a century it has emerged as something that and it's now treated, I think, almost with the same amount of like veneration as religion, when in reality we need to treat it as just one way of learning about the world.
As we now have new data volumes, new methods, new tools that allow us to take observational data and learn from it, and especially in healthcare, how do you see that intersecting with practice? And I think that's one area that we've always really struggled with is, because you can, if you have an algorithm that goes awry, we've seen it with the flash crashes in the stock market and other areas. It's one thing if it costs people money, but if you have an algorithm that makes a suggestion of gets a dose that's 10 times what it ought to be, and that doesn't somehow get caught. I mean, these are real dangers, it would seem, of how things can go wrong. We don't fully understand how
Sure.
the answers are being calculated.
Which, happens all the time. Even without the algorithms being the only, humans give the wrong dose quite regularly. But, oh boy, so there's a lot of things I guess I want to say. So in terms of the algorithms being, so when you're doing, when you're building models out of data, what are you attempting to create? You're trying to create one of two things usually. You're trying to create predictions, or you're trying to create understanding. You're trying to sort of evolve the mental model of the theoretical domain that you're working in. And so let's handle predictions first. It's often the case with predictions where you can actually remove the human from the loop entirely. And so I was recently at Medtronic, and they were talking about how for many of their devices, they're moving to a closed loop model. Where, for the delivery of insulin into the patient for diabetes, or for things like pacemakers, which are already closed loop, there's no human in that loop. It's a sensor sending data back to a control system, which is then affecting, and so you just have a complete automated loop. And so that's there's a certain level of certainty that you have to be comfortable with that. But then with things like clinical decision support, you obviously have this human being which kind of sits in the middle of that loop and is able to mediate between recommendations provided by the algorithm and then actual treatment decision making. In terms of how we prevent ourselves from going wrong in the way that finance goes wrong, I think that remaining close to tie it back to the very beginning of the question, which is how do we kind of link providing of care and the theory of which is the best care to provide. And you have to remain close to the thing which you create, and the thing which you create is understanding of predictions. So if you are generating predictions and sending them out into the world and not participating in their deployment and evaluation, then you're going to do much worse. So the more we can do there's actually a very nice talk in my world from a guy named Brett Victor who designs development environments for programmers, and he talks about creators need to be close to the things that they create. So it's the same notion of like when you build something, you have to watch it perform, and then you'll learn from how it performs to iterate and change what you've built. And the closer that you can hew to the representation of reality of what's actually happening in the process. So my experience on Wall Street, I worked there briefly, was that we began to like sort of the models began to slowly drift away from the actual physical practice of trading. So where I could be working on a stochastic differential equation for 2 weeks, and then I'd implement some numerical solution to it and wander down to the trader and talk with him about, hey, so how are you going to use this thing? I'd say, well, it's this market that just started 3 months ago, and there's 7 traders in it, and the guy from Goldman knows the guy from Lehman from school, so they often trade together. So we're trying to, and I was just thinking, like, gosh, like all this information, the mental model that this guy has in his head for what's actually happening is not present anywhere in my model. So the closer you can stay to the actual act that's being performed in this, universe of atoms here, the tighter digital representations hew to the realm of atoms, I think the better off you're going to be from creating these kind of really dangerous mismatches between theory and reality.
Interesting. one of the exciting developments I see occurring in healthcare and just in society in general is this explosion of data that we've never had before that we don't really know what to do with. So the idea we have, personal sensors, the Fitbit, and our phone is gathering and reporting data about us constantly. We have all kinds of apps and other tools that are gathering information, and most of that now sits within silos, that are hard to access. But it seems as those walls are coming down, and it's opening doors to completely new ways of information that we just never imagined that we would have, never imagined that we could have. So we really haven't imagined even what we might do with it. And particularly in the mental health realm, we have a very relative to many other areas of medicine, we have a relatively unsophisticated way of diagnosing. We have questions that we ask, and it's challenging. But now we have all this data coming in that could actually mean something. We might actually be able to tell based on data coming from a biometric device about whether someone is their depression is worsening or something like that. We don't know. How do you see? With that. But the data volumes are going to be something that we've never imagined, and the complexity of understanding all those relationships is challenging to imagine. How do you see tackling that kind of problem and opportunity? Because I think it could revolutionize how we approach care in many ways.
Yeah, it usually takes one visionary organization that imagines that there is value in integrating these data sets, and then that organization has to do the hard work of building the data model to represent the data that's being collected, writing the software tools that transforms the raw data into that data model, performing the analyses that then extracts some sort of signal from the data that's being generated from that new measurement device integrated with the data that people already have, and then takes those signals and uses that to alter the way some business process works, and then demonstrates the value to the organization. And then so kind of once you have that complete cycle performed once, then you have additional organizations that look over and say, that looked like it was useful. How did you do it? Let's try and do that as well. And before you know it, it starts to spread like wildfire. And so there's no, again, like I guess it's not a magic bullet. I mean, I was talking with somebody earlier today about how I was touring our Genomics Core facility just last night. And it's interesting because the person that runs our Genomics Core facility at Mount Sinai has been running facilities like this since the 90s. And you just talk to him about how things have changed. And we had ways of accessing subsets of people's, of the sequence of their DNA. For decades, and it's just been this like slow evolution of improving the measurement technology, improving the technology which is receiving those measurements, and then building a unified and coherent data set out of them, and then having the scientists build tools to work with that data set and draw inferences that are actually important to health. So you just kind of move through that cycle, and I think the more times you move through it, the tighter and tighter it gets till it becomes something that you hand to a computer and no humans ever think about again. So it takes the early stages are the most uncertain because there may not be value. We may postulate that there is value, but there has to be someone who takes that risk, who has that belief that there is value here, and we're going to allocate enough capital to actually evaluate whether or not there is value.
So as we have discussed our work through Knowledge Network and the data sharing and collaboration that we have, to really try to begin to leverage some of the value of data to advance mental health and substance abuse treatment across the nation. What, from your perspective, working with data on a large scale and working some in healthcare now, where would you like to see that go? What opportunities do you think we have, and what should we be thinking about as we move forward?
That's a great question. It's difficult. So through the work that I've done with Sage Bionetworks, that's probably been of the most relevant to the work that you guys are doing with the Knowledge Network. And so Sage began by, it was this set of assets that had been that Merck controlled for. It was hardware and software and data sets and models and people to build those models. And so they spun that out, and what they really wanted was to have researchers from both industry and academia collaborating in this single central place where all these data sets were gathered, and then you could have sort of lineage tracking, derivative data sets produced. And I think what they found is that scientists have a set of habits which make it such that all working together in one place is very difficult. So there are a lot of sort of side projects that spun out of the work with SAGE, where they worked on allowing scientists to be able to cite data sets rather than papers. So that was something that kind of spun out of the work with SAGE, and something that we tried to work on. And then trying to get funding that was delivered to scientists to recognize the value in data set citations rather than just paper citations. And then also recognizing and then figuring out a way to also give the scientists who had produced the data some sort of value capture for having produced it. So maybe you get exclusive access for 6 months or something. So trying to figure out, because those scientists were all very, hey, I built this data set, like I want to, milk it for all it's worth for my career. So those were some issues that we ran into. We ran into issues around consenting the patients who generated the data. So we ended up spinning out another thing, which was a consent form that, and it's totally escaping me right now. I woke up very early and flew from New York, so my mental agility is unfortunately reduced. But so we ended up having another side project in which we created a consent form, which we wanted to standardize the consent forms that people were using for research, so that you could actually recontact them, and you could do analysis on their data, which wasn't just specific to the reason that the data was collected in the first place. So we had to solve all these logistical issues that were not really technical, were not really algorithmic. When it came time to actually do the analysis, one of the things that we've found is that there's not a ton of value in being someone who has worked in the biomedical domain forever when it comes to building high-quality predictive models. So we actually recently joined with another nonprofit, the DREAM Foundation. And the DREAM Foundation spun out of Gustavo Silovitsky's work at IBM Research, where he was running contests for building predictive models, very similar to the Netflix prize. And so we now work with DREAM, and we actually are the same organization, I guess now. I don't know the exact organizational maneuvers that happened. But SAGE now runs contests to bring predictive modelers into the SAGE community so that they can work with the data sets there. So what we found is you can't just build data sets and hope people come. You have to kind of run these contests as a way to draw the predictive modelers to the data that you've collected in one place. So there's a wide variety of things that I think could happen. But again, at SAGE, we're not attempting to actually change clinical practice. So I think that we're kind of on the knowledge creation side at SAGE, and you guys are both creating knowledge as well as trying to use the knowledge that you've created to alter practice. So in terms of how that arm works, I have unfortunately fewer experiences and ideas, but obviously there are issues. And I mean, one of the things that's interesting to me about what you guys do is I think that if you try and alter the practice of well-educated and credentialed care providers, there's a tremendous amount of inertia. But if you're trying to alter the practice of people who are doing this, who haven't invested quite as much time in this magical credential that they've received, they're probably more willing to adapt the way in which they deliver care. So I think trying to go in through these community clinics rather than through the sort of highly credentialed and regulated care providers seems like a pretty promising path if you want to alter how treatment is done. In terms of delivering training and getting them to alter their treatment, that'd be, I guess some of my experiences at Cloudera, we've invested very early on at Cloudera, and we have kind of this new architecture for analytical data management. So we invested very early on in training and certification. And so the logistics of professional training, there's a surprising amount of budget allocated to continuing education. And I think that figuring out ways that you can tap into that stream to create this change in how care is done, making that part of the scope of the mission, like education and creating like real certification programs might be a very interesting way. So if there was some sort of, and this may already exist, I'm sorry, I don't know everything that you guys do, but if you had some sort of like, Centerstone certified care provider, the creation of those credentials tends to have value in shift practice, in my experience at Cloudera.
Good. I'm going back in my mind, and then we'll open it up for questions with the group after this. But you mentioned something about the way in the web environment people can do these sort of very rapid, hypothesis-driven, well, not even hypothesis-driven, empirically-driven hypothesis testing.
Mm-hmm.
How do you see that mapping to a healthcare environment? I mean, if you think about how do you begin to move, it's sort of easy to think about, well, you put up a blue version of a web page and a red version of a web page, and you see which people respond to better. But how does that map onto a healthcare question?
I think the biggest problem to solve is the frequency of exposure of the patient to the healthcare system. So the reason why we're able to run high throughput experiments in the consumer web is that we have all these lightweight contacts with individuals. And so one of the things that's very bizarre to me about how healthcare is delivered, like the system that we've built, it's a very low frequency, high cost interaction. So if you want to get care, if you want to somehow, healthcare is nothing more than a time series of interventions into some dynamical system, right? And so if we wanted to intelligently make interventions into that time series, like one way to do it would be to never sample. You wait for that time series to wander into your office and then make like a really aggressive intervention into it. But probably a much better way to build a control system would be to frequently sample, figure out a way to, at low cost, frequently sample that system and take much more lightweight interventions. So until we start to conceive of healthcare provision as a high frequency, low cost touch point with the patient, then you're right, we'll never be able to do high throughput experiments. So I think there's some work that has to go into how we conceive of healthcare delivery before we can start to bring in the tools of high throughput experimentation.
Do you have thoughts? I'm gonna steal one more question here
Sure.
before I turn it over. I think that's such an interesting question. It's one we think we've thought a lot about within Knowledge Network is what that next phase of healthcare looks like, because we're at this place where we have payment reform. We have new systems where we're talking about payment for value instead of fee-for-service type models. We have the influence of large-scale data, mobile technologies, sensors, these things. How do you see that? I mean, you've touched on it, I think, a little bit with this sort of, higher frequency, lower cost intervention. What opportunities do you see there for a redesign of the healthcare system? That's a really, really big, really unfair question.
Yeah. Well, so my wife runs a full service seed investment fund for digital health called Rock Health, and so she's got exposure to a lot of people who are trying to build. And so the way that she decided to start this nonprofit was she worked at Apple, and she was responsible inside of the App Store for the healthcare and medical verticals. So she watched all the different apps that were coming through and was just very frustrated by the quality of design and technical talent that was creating solutions that ran on these ubiquitous computing platforms for those verticals. And so with Rock Health, she's really been trying to bring the technical and design talent of Silicon Valley into the healthcare and medical verticals. So obviously the mobile devices and tablets are incredibly powerful ubiquitous sensors and effectors that we can use as kind of the vector for that touch point between the healthcare system and the patient. So now kind of figuring out how do we take this notion of healthcare delivery that we've been stuck with for decades and decades and evolve it to a world in which we have these ubiquitous devices. So the challenges are going to be sort of reconceiving treatment. And so I was talking with someone earlier today about the kind of paradigm, the early the preview, I guess, of what this is going to look like is some of the home care devices for senior care. So if you want to get these like very high frequency measurements of a patient that's then actually available to the clinician. It seems to be some of the devices that are being put into the homes of seniors might be the kinds of things that are a preview of what we'd all be, what we'd all have someday in the future. So yeah, I think that the hard part is going to be figuring out, are we headed for a true direct-to-consumer future where people like Nike are actually going to dominate the healthcare sector because they have this direct channel of selling the sensors, and all of a sudden if you start, if you're able to start perturbing behavior via the platform that is the sensor, then perhaps that becomes that usurps the role, a vast majority of the role of the traditional healthcare system. Or is the traditional healthcare delivery system going to evolve to kind of subsume these direct-to-consumer sold devices into how they provision care? And that one, if I had to guess, I mean, there's a reason I'm at Mount Sinai, and I'm not trying to build a direct-to-consumer product. So you kind of, I'm surprisingly, I guess, given my origins, biased more towards the stodgy, heavily regulated industry versus these startup companies. But it's, to be honest, I don't know, right? Like nobody knows. So that, I think, is the real tension of the next 5 to 10 years. It's going to be interesting to watch it play out.
Well, I want to thank you again for coming. But before we finish, I want to open it up to the group to ask questions. So it's.
So we had an experience where patients are interacting with the provider. They basically collected lots of data, there's a visual display, data, provider and patient sharing together, and having interaction. So did you hear that question? So I'm talking about, have you run into situations at Mount Sinai or your work where through whatever the patient's doing, they've collected this massive amount of data, and it's being visually displayed in a purposeful way during the physical encounter and the patient and provider. And is that making a difference? Are you seeing those things happening? Because I've got a mental model that's what changes in the interaction. Is it's not just the production of the data, it's actually the review of the information and the interpretation of it together.
Sure. I personally have not sat with a physician and a patient and observed that interaction, but I do know that within the Department of Genetics and Genomic Sciences at Mount Sinai, we have projects in which we are working closely with physicians about the joint review of their genomic data integrated with their clinical data set. So we have 2 different projects that are doing precisely that. They're building web interfaces that the patient and the physician are expected to look at together to better understand their what's in their genome. So you could think of it as sort of a clinical version of 23andMe. So yeah, I think that there's empowering. A lot of people talk about shifting the power dynamic of just the doctor telling the patient what to do to kind of patients and doctors collaborating on things. And so that's definitely something that we're thinking about with bringing genome data into the clinic. Whether the traditional parts of the hospital are rethinking that, I'm unfortunately not privy to those discussions.
Other questions?
First, as a lifelong fan, I got to admit that I'm losing faith in that team that you have. Very good. Yeah.
Fair enough.
Yeah. Anyway, you strike me as someone who works in quantum leaps. You are frenetic in that development. Is there a quantum leap you see in the physical health / mental health world where you sit? It's the next quantum leap that we should be thinking about, maybe not even knowing about?
That's a great question. If there were any sort of quantum leap, it's probably going to come from the microbiome people. So the people looking at sort of the bacterial composition of your body. So if you just look at cell count of kind of the organism that you are, 90% of the cells belong to the bacteria. They're just kind of inhabiting your gut and just kind of all around you. And so there's these like remarkable links between the gut and mental illness, and just like the locus of agency of disease like the biggest quantum leap that I could imagine from my deeply uninformed perspective on health. It seems to be, if anything were to just sort of like completely change how we think of mental health in our lifetimes, I would suspect that's the biggest thing that could just be a total change. I think that the genomics work wouldn't necessarily be a quantum leap, but hopefully it will be an evolution in understanding. I mean, the biggest thing is just biomarkers for mental illness, right? Like that's what everyone is waiting for, is like when can we compute a number and then align that to a treatment regimen rather than having to just talk to someone and use that to generate treatment. So there's, so one of the things that drew me to Mount Sinai is that the dean of the medical school is a psychiatrist himself, and so his name's Dennis Charney, and he's done a lot of work in this domain. So he's done some interesting work on like ketamine and for depression, and he's done some interesting work on finding people who are sort of robust to traumatic situations. And so he's a very interesting guy to talk with. And his, one of the things that he really he's invested a lot in our neuroimaging department. And he's kind of specifically asked me to look at doing a lot of intelligent things to control for covariates and do matching and things. And some of the diatribes about the methods were unbelievable. There were op-eds basically just saying like, to even utter the words observational study is we shouldn't even be considering this. I can't believe that this is being published in a scientific journal. So that, I guess, there are people who are, I think, a little bit too far polarized against. So I don't think we should just throw out randomized controlled trials and put our faith only in causal inference and observational studies, but I think that there's a lot of value in that. I think that the tools for doing causal inference and observational studies have evolved. I was surprised myself when I sat down to put together the curriculum for this class. I was going to teach a segment of the class on longitudinal data analysis, and I just started kind of digging in, and I thought it was remarkable the rate of improvement of these tools for causal inference and observational studies since the 70s. So I think that maybe there's a bit of a curriculum update that's required to take some of these new tools that have evolved at kind of the forefront of quantitative social science and push them into basic, and actually, I mean, epidemiology has been also at the forefront of this as well. So take some of the tools that they've evolved there and push it into kind of standardized statistical education. So we're not just only thinking about randomized controlled trials as the way of getting at objective reality, whatever that is.
I think from a time standpoint, do we want to take one more question and then we'll wrap up?
So you mentioned confidentiality, consenting, and whatnot earlier in your talk. I'm curious around specifically the tools and the applications that might be used to directly engage with the patient and collect data. Do you are there special challenges in terms of rights, privacy, healthcare privacy, and do you consent everyone? Is there a blanket consent? How do you work within that?
That's a great question, and again, this is not my area of expertise, but I've stood next to people who are experts in it, so I feel comfortable commenting on. I think that we need to move towards a more kind of machine-readable representation of consent, and so that's some of the work that grew out of our work at Sage, where it was not just evolving what was in the consent form itself, but it was also evolving the representation of what had been consented with that data set. So there's a nonprofit that's spun out of the Broad Institute at Harvard called Genome Bridge, and they're trying to build this centrally, it's very similar to Sage. They're trying to build a centrally aggregated set of data around genomics data, and what they're finding is when they get data from their partners, there's no metadata about how that patient was consented. So they don't actually know how to use they don't actually know what they're allowed to do with that data. So it's not just about coming up with the right consent form for people to sign. It's also coming up with a standard for representing consent in a machine-readable fashion that can be attached to every data point and can be exchanged between partners and providers. So that's an area that I feel more comfortable commenting on in terms of how you educate people about what their data could be used for and navigate them through what they're okay with consenting. I'm not a medical ethicist. I don't I don't know as much about that, but I can say the problems that I see with consent are, number one, giving everyone a standard that's actually friendly for research. So a consent form that everyone signs by default that allows them to be recontacted for further research and allows downstream analysis, not just for the purposes of the original analysis. Those two things are the things that are like the linchpins of the work that we did at Sage. And then coming up with like a machine readable form of representing what was in the consent form and attaching that to the data that gets generated and ensuring that's sort of a standard. Because if we really want to do data sharing, we need the consent form to travel with the data.
Very good. Well, I just want to, again, thank you very much for taking the time to come down here and talk with us today and share the benefit of your experience and think about what that might mean for the work we're doing in mental health.
Yeah, thank you so much for having
Thank you
me.
very much.